Hello. We're going to talk about topic 1.9, connecting multiple representations of a limit. Ultimately, I have a piece of notes here that has some functions. It has some graphs. We're going to try to answer some questions using a variety of different representations. So let's start with number one, or the box on the left. Okay. I give you three functions, f, g, and h. All right, and we're going to use those three functions to answer these questions. Trying to use proper notation along the way. I know there's not a lot of room to write, so we're going to do the best that we can. All right, so I want to evaluate the limit for number one as x approaches -4. It's a two-sided limit of f over g of x. So when I do a quotient, I'm going to do the limit of f of x as x approaches -4. And that's an x squared minus 3x minus 28. And I'm going to do that all over the limit as x approaches -4 of g of x, which is just x plus 4. Now, if you substitute in, if you do a direct substitution here, you're going to end up getting 0 over 0, which is indeterminate. So what we need to do is we need to reduce this. We need to kind of factor and cancel, factor and reduce. So if you reduce the top, it factors into x minus 7, x plus 4, all over an x plus 4. The x plus 4 is reduced, and I'm left with an x minus 7. Now, this is our extended function, which we can then use to find our limit. So I'm going to take the limit as x goes to -4 of my extended function, x minus 7. And if you substitute in a -4, I get a -11. And that will be my answer. Okay, so I always like to show that indeterminate form first using proper notation, limit of the top over limit of the bottom. Okay, so I'm going to do the same idea for the next one. We'll kind of change colors up here. For number two, I'm going to do g over f. So I'm going to kind of flip-flop it, but we're going to do it as x approaches 7 instead. So the limit as x approaches 7 of x plus 4, that's g, all over the limit as x approaches 7 of x squared minus 3x minus 28. Now, if you evaluate these two limits, if I plug a 7 in, I'm going to get an 11 over, and if you plug 7 into the bottom, I think based off our factoring that we did earlier, we should get a value of 0 here. Now, this is not an indeterminate form. This is not even if you factor and cancel, it's still not going to change anything because if we get a constant in the numerator and 0 in the denominator, ultimately this is undefined. There's a vertical asymptote. Therefore, my limit, oops, I wrote wrong word, not done, but does not exist. Okay, and that would ultimately be my answer. Because there's a vertical asymptote, we can't have a limit there. All right, and then last but not least, we're going to go -4 from the right. I want to make sure I write this correctly. Again, we're going to change some colors. I'm getting a little cramped in here. I apologize. I'm going to say the limit as x approaches -4 from the right of, we have g on the top, so that's x plus 4. And then on bottom, we're going to have the limit as x approaches -4 from the right of h, which is a -2 times the absolute value of x plus 4. Okay. Now, we learned in an earlier section of how to deal with these absolute values. If I'm going from the right, then I'm going to use the positive version of that x plus 4. So ultimately, this does come out to be 0 over 0. It's indeterminate, but I need to use a form that's going to be a little better. And I'm going to kind of squeeze this in here. I'm going to use the limit as x approaches a -4 from the right of x plus 4 over a -2 times a positive x plus 4. And those would cancel, And I would be left with, I'm going to write my answer over here just because I ran out of room. My answer should be a -1/2. Okay? So let's go to the box to the right here. We're just going to keep moving on. So the graph of f of x shown above has a vertical asymptote at 6. So that's important. We need to know that this is a vertical asymptote. Okay. Use the graph to evaluate the following limits. If the limit does not exist, write it does not exist. Okay. So the limit of f of x as x approaches 2. Now this is a two-sided limit. So if I go from the left and I go from the right, it is going to the same value. So ultimately, I know that limit's going to be a -2. For number 2, as x approaches -1, let's erase these little arrows here. As I go to -1 from the left and from the right, those two pieces of my function are not approaching the same value. So this does not exist. Okay. For number 3, so let's keep going. As I approach -1, now remember when you have that little negative there as your superscript, that's from the left, so that's going to be this arrow here, and that is going to be at a value of -2. And number 4, as I approach 6, well, there's a vertical asymptote here at 6, and from the left I go to positive infinity, and from the right I go to negative infinity. Those aren't the same anyway, so this also does not exist. Okay? Next, we're going to try to sketch a graph that meets the following guidelines, right? So using these characteristics of our limits, I want to make one graph. So as x approaches 1 from the left, I got to be at 2. And as I approach 1 from the right, I got to be at -1. So as I approach 1 from the left, I have to be value at, it's got to be going to 2. If I go from the right, it's got to be at -1. Again, you could draw your arrows however you like. The important thing is that it's going to those y values at -1. And then g of 1 is going to be 0. So that's going to put a closed circle at 0. And that would be my graph. Let's do one more. The limit as x approaches 2 from the left. So as I approach 2, there's my 2. From the left is going to go down to -infinity. As I approach 2 from the right, I'm going to go all the way up to positive infinity. As I approach negative infinity, so as I go to the left side of my graph forever and ever, it's got to go to a value of 2. And as I go to the right side of my graph, it's got to go to -2. Now we have to connect our function appropriately here. So I'm going to start on the left side. I'm going to connect my arrows together, and that gives me a little graph. And I have, even if you want to make your graph look a little better, there's a little vertical asymptote here at 2, which is making it go to positive and negative infinity. Okay. Last but not least, this is where we're going to connect them together. So which limit from the upper right corner does not exist for the same reason or problem as problem 2 on the upper left corner? So problem 2 does not exist, right? So which one of number 2 or 4 from the right box doesn't exist, but which one doesn't exist for the same reason? Well, ultimately, the reason for number 2 on the first section is because I have a vertical asymptote. But in the second section, I just need to figure out at -1 or 6, which of those is a vertical asymptote, and it's going to be at 6. So I'm going to say question 4 does not exist for the same reason. Okay, and that reason, of course, is a vertical asymptote. For number 2, sketch a graph of the limit described in the first problem from the top left corner. So I want to sketch a graph for this f of x over g of x. Now, if you notice, it was a rational function. The x plus 4 is canceled, so I know I have to have a whole at -4. So I know the extended function is x minus 7. So here's how I make that graph. I am going to draw my coordinate plane, okay? I am going to graph x minus 7, which of course, 5, 6, 7. It's going to have a y-intercept way down here. It's going to be linear, okay? Now I'm going to run out of room so you guys can learn from my mistakes when you do this on your note sheet here. Okay, so I'm just going to write into the next problem. But I have to have a whole at 7. Okay, there's got to be I'm sorry. I got to have a whole at -4. So at -4, 1, 2, 3, 4, I have to have a whole here. Okay, and then I'm going to have a point or an output at -11. Now I'm way out of room here, but I am going to have a point way down here. Okay, so that's kind of what it looks like. So at -11, there would be a value there where we would have a point. Okay. I know I wrote over my problem for number 3, but we're going to finish up here. Using problem 1 from the bottom left corner. Okay. Explain the difference between finding g of 1 and the limit as x approaches 1. So g of 1 is the output of g of x. Okay. The limit as x approaches 1 of g of x is what the graph approaches from the left and right side. Now these two things aren't always equal. You need to understand, I guess, a big concept here is that if I just take the g of a number or f of a number for that matter, I'm just looking for the output. Substitute in a direct substitution. What do I get? A limit. Sometimes a direct substitution doesn't work, so I need to look at the graph or evaluate it to figure out what is the graph approaching. Always be sure you're looking if it's a one-sided or two-sided limit. In this case, for problem 3, it's a two-sided. So I need to know what it approaches from the left and right side, and just kind of a little extra piece of information for number 1 in this problem. From the left and from the right are not equal. That would not exist. However, g of 1 does exist. Okay. Hopefully this helped, and I'll look forward to seeing you in my next topic.